and welcome out there. We're so glad to have you tuned in this afternoon. A little dreary outside. Some of you are getting rained on. Some of you just got cloudy skies. It's kind of nice. But I mean that, hey, you know what? What's good about that? You all are watching Mathline because you're not outside. I love it. Hey, we want you to tune in and we want you to call in, all right? That number, 844-686-2378. I'm Ernie Roberts. I'm your host for this afternoon session of Mathline. You don't want to miss out on it. It's a lot of fun here. We'll talk, we'll work out math problems together, but we need you to call, all right? 844-686-2378. Go ahead and hit those numbers because you know what? We're going to depart for just a little bit to do a problem of the day, and we'll be right back, all right? But give us some calls while we're going there. Again, 844-686-2378. We will let you talk to our operator. He will get you taken care of, put you here, and we'll talk live on the air. What better thing could you ask for? Except for our problem of the day, of course. Let's check it out. Says, oh, it's trick-or-treat week, isn't it, folks? Oh, yes, Halloween is coming very soon. After trick or treat, Jasmine discovered that she had 27 candy bars. Woohoo! Good job. Making up, 45% of her candy treats. How many treats did she collect in all? Trick or treat. Woo! All right, well, let's talk about those treats. See what we're going to do. This, obviously, there's the percent right there, which gives me an idea and gives all of us an idea. This has to do with a percent problem, basically, disguised as trick-or-treat problem, whatever. And we already know how many candy bars she has in her hand. She's been out trick-or-treating. She got a lot of other types of treats, all right? The bars were one of them. Maybe she has a candy corn. I don't know. You know, there's different kind of things. So what we want to know is what was the total number of treats that she collected in all? In other words, where did we start? You hear me a lot of times talk about how to set up a proportion with percents. You've got the part, we have a base, where did we begin? And we ended up with this percent, and we'll put that, as always, we put percent over 100, because that's what percent really means, divided by 100, or in this case, it could be 45 hundredths of the candy. The question I want to ask here, while you're thinking about it, is, what's going on over here? It's pretty easy to figure out percent's going to go over 100. So we'll put a 45 right in that slot. But now the big thing is, do we have part or base? Remember, 45% sounds like a good part to me. So I'm going to put the 27 right there because we want to figure out how many treats does she have to begin with in order to make that 45% give us the 27 candy bars. So we'll put those two together, and we're going to put our unknown right there. We'll put an N there for a number. How about it? Hopefully it'll come out even, because I don't think you can get a half a treat or a third of a treat. No, if you do, you better throw it away. I would not eat that. So let's see where we're going to go with this. It's set up as a proportion, and what happens here is we're going to cross multiply. All right, we're going to multiply on the diagonals, all right? So you're going to take, and we're going to take, because we're going to work it together. Some of you are working at home. Some of you have already made mention of it on Facebook and such. But let's go ahead and work through this great thing. We've got 45 times n equaling, it looks like, 27 times 100. Now, we multiply by 100. That's easy. Add a couple of zeros, and you get 2,700. That part works beautifully. Now, over here, here's what the deal is. We got to deal with that 45. That was easy to get 2,700. It's not so easy to get to 2,700 divided by 45, because that's where we're going at this point. We are going to clear the 45 there. We're going to divide it through both sides. Good old division property, equality, you got it. So let's run it and see what happens. I think that's why we had calculators invented, right? To do numbers just like this. So let's go ahead and take 2,700, and we'll divide by 45. Oh, get something really nice there. That is really nice. So we're going to get this n equals 60. Woohoo! All right. So if n equals 60, what are we talking about? How many treats? Right. So those are the treats. What we're looking for. Can't we do a quick check? In other words, if I were to take that's number 60, and this time multiply it by 45%. In other words, we're going to go back, kind of work it in reverse. Remember, we divided to get to this one. So let's take our 60 times, and we'll change that to a decimal, all right? Change it to 45 hundredths. And again, I'm going to cheat. No, we're not going to cheat. We're going to use calculator and see if we come back to 27. We should. So we have 60 times your 45 hundredths. 45 we love to call it. I know. Entering, and we get 27. So there we go. This is our check right here. This is how we check it back through. And we always want to make sure, does the answer make sense? And it certainly does. We have 60 pieces, get 45% of that. We are back at 27. So there you have it, folks. Problem of the day. By the way, tomorrow evening, I sometimes get tied up because we have people call in during the show and such, and sometimes we have a caller at the end. I just want to make sure tomorrow evening we're going to be doing a Halloween special. Yes, we're going to have fun with it. It's dividing fractions, but you'll never see dividing fractions done like this ever again, probably, except on Halloween, it seems like, on Mathline. But you can also check us out. Of course, this one will go on to our YouTube channel very easily there. But my point is, have a safe night trick-or-treating tomorrow night. But if you're going to be in, some of you are going to be rained on. So stay and watch Mathline and wait for the rain to go away and go out later, all right? But right now, what we're interested in is getting some calls. 844-686-2378. But again, like I said, at the end of the show, sometimes things get a little busy, and I forget, and I don't remember that I need to remind you to watch us tomorrow night. Specialized segments, not a call-in night show, but it will be a lot of fun for you to watch. And then go out and trick-or-treat, okay? Hey, use your time. Use your time wisely. In the meantime, let's get those phones ringing. Again, that number, 844-686-2378. Let's talk about some, we just used some decimals and percent, and I just moved a little bit back and forth between them. Let's talk about fractions, decimals, and percent just a second while we're waiting for those first phone calls. And again, we will take care of you. And if we hear a phone call ring and we get it, we'll go right to you. We'll take care of you, all right? But we're here to help you. Remember, tomorrow night, we're not going to be around to help you out tomorrow night. So this is your night. This is your chance to give us a call, all right? 844-686-2378. Let's talk about how we can work 3/8 into a decimal and to a percent. And I'm going to go right straight to the proportion approach that we did, and I'm going to show you another way to go just to the decimal. But let's go for a percent using the proportion, all right? So starting with, again, right, I love that, part over base. Look what we're saying. We're talking about 3 out of 8. So there's the part, there's the base. How about that? Equals, this time we're looking for that percent, which we're going to plop it over 100. So we're going to use this approach. This proportion is an awesome way to figure out answers and things of this nature. So remember, folks, it's going to give us a percent, and then I'm going to show you how you can get a decimal, and then you're going to say, oh, there's a nice connection, as if you didn't know that already, correct? So let's put some numbers in here and see where we're going. We've got 3 over 8 equaling n over 100. Don't know what the answer is? Well, maybe some of you do already. Maybe some of you already figured it out. Let's play this thing out and see what's going to come to pass here. I've got it going here. I've got 8n equaling, you know what I did? I cross multiply, didn't I? So we need to remind you there, we're going to cross multiply. Let's play that cross multiply game here. 3 times 100. I tell you what, proportions, cross multiplication, one of the best things ever came around, all right? Because not only do we work percents and things like that with, we work similarities, we work, like I said, proportions where we figure out dosage of medicine, things like that, what needs to be, what part of this, part of that. It's a great, great mathematical tool that's so useful in the real world. But let's get this thing going here. How about it? 3 times 100, we got that, 300. And so it'd be 8n equaling to 300. Oh, just made them have to, I'm sorry, drop that lower third. Just remember, we got to get you some calls, all right? 844-686-2378. Now, back to this problem. Let's divide both sides by the 8. Because that's what we do. 8 times what number gives us 300? Now it comes out even, but not really like we like in terms of an integer, but we are going to be able to get a nice, even final answer that's not going to have anything worrying about, knock off, carry away. It's going to work out very nice and smooth. Let's take a look at that. Let's clear what I've got there, all right? Now let's see what we've got. Take our 300 and divide by 8. And I said it would go evenly, and it does. Here we go. Our n value here is 37, and I'll put that decimal there, just like it said, and that's a percent. So it's basically 37.5%. Pretty nice deal. Now, let's think just a second, back to this number. I had Gary Petco here, we would also already be telling me, look at the benchmark, so to speak here. You know it's got to be less than half, right? 3 is less than half of 8 because half of 8 is 4. So if it had been 4 over 8, we know it would have been 50%. So we know it's less than 50%. We get a good estimate on that. We also know if we had 2 out of 8, it would be 25%. It would be a fourth. It would be a quarter, if you will, all right? So we know it's somewhere in there, and it's exactly between 25 and 50. So there's your percentage right there. Now, what else could we have done? We could have done the long way, and this is for some of our younger students here. Let's see what would happen if we had decided to just divide 8 into 3. You say, well, you could do that on the calculator too. We sure could. We certainly could. But let's do it as so many of us do at school right now. Many of our students are saying, you've got to crank it out. You do not get to use a calculator to find out what 8 goes into 3, all right? So let's put our decimal right there, play the game, put a 0 in there, and let's transition. That's what we're going to be doing. And by the way, these are the kind of things that we've been doing in our specialized segments Friday shows lately, is working with decimals, fractions, and percent relationships. And hopefully you've been watching them, and if you have, you know there's some tricks. There's some things that we've learned that make things go a little faster. So let's do a little division here right now, and let's catch where we're going here. Ooh, how about it? 8 goes into 3? No, it doesn't. 8 goes into 30, however, very nicely. It'll go 3 times. And we're going to multiply. 3 times that 8 gives us 24. Let us subtract, because that's what we need to do. And we get 6. That didn't really help much, did it? That's something left over. So let's do another 0. Bring it straight down. And let's see if we can deal with 8 going into 60. And it's nice to know those multiplication facts. That's going to go in there. Well, if it goes 8 times, it's too big. That's 64. We want to stay under. So it's going to go 7 times, which gives us what? 56. And now we subtract again. So let's think about money. 60 minus 56 gives us a 4. Going to keep the game going one more notch here. Let's put another 0 in. And let's bring it all the way down here to 40. And I see an end to this problem. I do. Because 8 goes into 40. That goes exactly, you got it, 5 times. So we got 5 times 8, which is 40. Nothing left over. Came out to the finish. Now, one quick thing before we go and talk about comparing this answer to this answer. What do you notice? Decimal is going to go what? Straight up. There, straight up. So we actually have 375 thousandths. That's with a th on the end of it there, folks. With a th. Whew, thousandth. That's funny to say. Now, where are we going to go at this point? Notice we had the decimal and then 375. Over here we have 37 and then the decimal and a 5%. You ask, Ernie, that looks like the same answer pretty much. And it is, because when we change from a percent to a decimal, we simply move that decimal 2 places. Because basically we're now dividing this number by 100. Remember we said n over 100. That will give us the decimal. How about that? Or here, we're looking the other direction. We're going to go from here to here. We're multiplying by 100, which moves the decimal to the right and takes us to here. But notice there is a nice relationship. This has a percent. This one does not. It still represents 3/4. It still represents that fraction. So take that a little grain of thought, a little bit going on there. Like I said, tune into us on the Friday specialized segments. We'll see some more moving back and forth between fractions, decimals, percents, and maybe even starting with the decimals and percents and going back to the fractions. We do all sorts of stuff right now in that series on Mathline. So you don't want to miss out on that. Friday, I'll be giving you a Halloween special going on. And while we're at it, speaking of some special good stuff, let's take a look at Mathline today. See what we got. Hey, Mathline.
Hey Mathline, I'm Walker Chesley from Powell High School in Knoxville, Tennessee. Here's a problem for you. What are the solutions to the equation absolute value of 3x minus 9 equals 12?
Okay, Walker, what are the solutions to the equation? And you've given me, and notice he said solutions. And let me tell you a little about Walker. Walker's having a great season as quarterback for the Powell High School Panthers. They are undefeated at this point. They play again this week. Don't know the outcome yet. Hey, I don't know the future, but I got a feeling if they keep the same thing up, it's going to be an undefeated regular season for them. So anyway, great job there, Walker. Thanks for being a part of our show today. And he's given me a problem. Let's take a look at it, my friends. It's an absolute value problem with the bars here. Thank you, Walker. At least we've got them isolated to begin with. So this is our story. And the question is, how am I going to get two solutions? Because so many of our students, at least when I teach Algebra 1, I see students that say, oh, 3x minus 9 equals 12, done. No, half done, all right? You've got one of the answers. We got to figure out how to get the other possibility. So what's going on here? There's a quantity inside the bars. Now, just a little off to the side here for just a minute here. If I were to say the absolute value of 7, you'd say, Ernie, that's 7. That one's easy. If you put a number in there, it's real easy, isn't it, guys and ladies? Now, what happens if I put a negative 7 in there? And you say, answer's still 7. Lucky numbers, aren't they? I don't think 7's the answer here, by the way. Well, we may find out. It may be different, but I don't, I may have given something away here. Doggone. Oh, well, such is. We may have at least one of our answers there. I believe we do. So some of you are going like, man, you just give it away, don't you? What's the deal, though? What is the whole point of absolute value? What are we talking about? We're talking about how far on a number line is this number that we're putting in, or this value, the expression we've got here, this 7, this negative 7. How far away is it from 0? It's the distance. So in case it's the distance, folks, it's going to be positive. Negative 7, yes, it's to the left, but it's still a distance of 7. You don't have negative distance, all right? You don't go back. Even if you drive in reverse on that car, guess what? The odometer keeps going forward, all right? If you ever noticed that, have you ever thought about that? Maybe not. But if you could really peel off those numbers off your odometer if you could just drive all the way backwards to Nashville, but it'd be a little dangerous probably. Anyway, but I digress. But the whole idea of absolute value here is how far away from 0. So we're going to look for a solution that's going to give this quantity to be 12 units away from 0. Now, how many ways can they be 12 units away from 0? Well, positive 12 is pretty easy. That's to the right on the number line. But to the left, we also have the possibility of being negative. Oh boy, not the negative 12, right? So 12 units to the left is also a distance of 12. So let's take a look at this problem, and we're going to take away the bars. Take away the bars. And we're going to write just what I said, equaling to 12, okay? Now, the other side of the coin, remember there's two sides of this coin because there's two solutions. We're going to look at 3x minus 9 equaling to the negative 12 version, okay? So that's the thing. That's where we're going to have two answers coming out of here. As I said, the first one looks pretty easy. And once you set up the second one, it's easy also. So let's play it out and see. And by the way, you know what's going to have to happen. We're going to have to check and see what do we come up with. Not a 7 this time, but we're looking for a 12 to pop up here. But there is a 7 involved in one of the solutions, but not necessarily both of them, all right? So let's see what happens. We're going to add 9. We know that game. We're going to add 9 to both sides here, Walker, all right? And we get 3x equaling to, how about it, 21. And as I gave it away, we're going to let x equal 7 on this one. And we'll check in just a second to make sure that after all that giving away the answer and the solution, all those good things, that it really is 1. All right, we're going to check it. I think some of you can already go ahead and check it and see pretty well you're going to get a 12 out of that. But let's move on. How about this one? Add 9. And let's see where we go. We get 3x again, which we thought we would. But over here, things got a little different. We didn't end up with a 21. Some of you are probably going, is it going to be negative 21? No, not going to happen here. It's going to actually be negative 3. All right, that's our story going here. Now, divide both sides by your 3. And we have x equaling to negative 1. So my two solutions right now are 7. Put a 7 in there. How about it? We get 21 minus 9. Bang. That works beautifully. Gives us 12, all right? And again, remember, absolute value of a positive 12 is 12. I remember also in teaching Algebra 1, sometimes students, for some reason, get in the head that this is just basically whenever you get here, you're supposed to get the opposite sign. That's not the case. We're looking for the positive version here, all right? If you wanted to get an opposite sign, you'd put a negative out here, and that's not what this problem is asking, not what Walker asked for. So this is what we're taking, all right, what he gave us. Now, how about the negative 1? We'll put that back in here. Let's put that in here down here. Let's see what happens. If we take that out for just a minute, guys, thank you. 3 times negative 1 minus 9 inside the absolute value bars. Do we get 12? All right? That's how we're going to check. That's how we're going to check. Over here, we put in the 7 back into the original equation. We've got a positive 12, but the absolute value of 12 works. Question is, will we get looks like a lot of negative business going on here. I'm seeing, and keep the bars for one more round, negative 3 minus 9 to equal 12. And yep, we're going to get a negative 12 out of that. And my friends, the absolute value of negative 12 does equal 12. So that checks. That one surely checks. So there are two solutions, x equals 7 as well as x equals negative 1. And again, points that I make on that I reference, just because you got a positive 7 doesn't mean you're going to have a negative 7. In fact, it means because you got that minus 9, it's going to change things. All right, so you are definitely going to have different numbers here, not just necessarily a 7 and then the opposite of that. Okay, you got different absolute values going on in that picture right there. Oh, I just said absolute values, didn't I? Those numbers. That's what's so cool about it. How far away from 0 are you? And that's definitely two different locations in respect to this. But they do solve the equation. There you go, Walker. I'll try not to get myself into more trouble. And good luck, Pal Panthers, on this week in your final games of football. How about it? Waiting for some calls. 844-686-2378. We'd love to hear from you this Wednesday afternoon. Reminder, we're not going to be back tomorrow because we're going to be celebrating Halloween with everybody else. And hopefully you all will have some great times out there trick-or-treating. We've gotten you ready for it. We're going to give you a send-off tomorrow night on Mathline that you want to watch. Then go out and do your trick-or-treating, and you'll have a great time. But let's look at one more little problem here. Yesterday we played with some triangle pieces. And sometimes we see pictures that we call composite figures, where things are thrown together. And in this case, we got two triangles that look like almost they make one big four-sided figure. I was about to say rectangle, but that certainly is not necessarily the case. Even if we had gone out here a little further and brought this over, it doesn't necessarily mean it's going to make a, how about that? Doesn't necessarily mean we're going to have a rectangle. But we're going to have two triangles we're going to work with. Let's set up some equations. Both of them have right angles here. So we know the good news is we got 90 degrees there. And let's look at how about it looks like kind of greenish there. Let's go with the one that has X in it. And we can look at two ways here. We could spot and say, wow, in a right triangle, if we used up 90 degrees, we know these two add up to how much? Say it, you got it out there, add up to 90. So there's one option right there. We could say 4x plus our 40 equals 90. Now some of you said, well, Ernie, I thought there was 180 degrees in the whole triangle. There are. You could also have added plus 90 equals 180 over here, but it's going to get you the same answer. All right, it's just starting you a little bit closer to the finish here. Now let's talk about our gold triangle over here, our yellow triangle as it may be coming across to some of you on the screens there. Again, I've got a 90-degree angle, so what do we know about these two guys? They add up to 90 also. All right, so we can pick up our 5y, and we'll add 50, it looks like, and that also will equal 90. Once again, we could have said 5y plus 50 plus 90 equals 180, but why not? Let's save a little bit of time, save a little bit of momentum. We're going to get the same answer when the smoke clears here. And let's clear some smoke. How about it? Everybody ready for the smoke clearing? I am too. Let's see. Let's subtract 40. And we're going to have 4x equaling 50. Can we divide it in there? Oh, yes, we can. Let's do it. It's going to go in there. Uh-oh. Doesn't quite go in there evenly, does it? I think we're going to get like, what, 25 over 2? That doesn't really tell me much about it. Oh, it does tell me a lot about x. It means the angle. We know what the angle is going to be. The angle is going to have to equal 50 there. But how about it? Let's go ahead and put it 12. Let's put it 12 and a half right there. Those of you like that point. Or you could write it with the fraction, use the decimal. That's a point right there, okay? The big decimal point there. Make sure it got in there. Now, our little guy over here does a little bit nicer for us. We always like things when they come out even, don't we? So let's subtract our 50 off both sides. Run that subtraction property of equality through this thing. We have 5y that equals a nice pretty 40. Why do I call it a nice pretty 40? Because it's going to divide evenly with the 5. I like that. And let's do that. Y equals to 8. Quick check. 5 times 8 does give us 40. 40 plus 50 and 90, we get 180. Back over here, let's try the same thing. 4 times 12 and a half. How much do we have? 50. Add 40, you get, and 90 plus, you get the 180 back. So in that case, different ways you can solve the figure, but remember, you're using 180 degrees in a triangle, or the fact in a right triangle, these two acute angles are also complementary, which means they add up to 90 degrees. Little geometry information for you guys out there today, all right? Hey, thanks for tuning in, my friends. We've had a good day. Let me remind you, we got Facebook going on, so don't forget about that. We do have our problems of the day that are getting posted there. And how do we get there? Let's see. How do we get there, guys? Can we show it real quick? There we are. Like us, love us, share us at www.facebook.com/Mathline online. We love it when you do that. Also, we got our YouTube thing, and I guarantee you're going to be able to find our Halloween special there if you look close in the next few days. So subscribe there, www.youtube, and you've got it. Hey, thanks for tuning in this afternoon. Safe trick-or-treating, safe Halloween to everyone. We'll see you again the next time.